In this ALEKS objective, we're looking at the hypothesis tests for the difference of population means using a t-test. So we've seen this in the confidence interval section, and what we are trying to do is determine if there is a true difference in the population between two alternatives or two independent groups, and we can use a t-test to do this. So in this problem, Amy's traveling two different ways. And on each freeway, she's recorded the amount of time it's taken her in minutes to travel down them. And we are trying to decide whether or not the mean travel times of the two routes are different or the same. So the first thing to keep in mind is that we have to use the pooled sample variance in order to eventually get to where we are going. So that's one of the things to keep in mind. And we know that that is equal to this equation down here. And I'm sure you can hear my dog in the background. She is not happy that I am ignoring her to do statistics. Hopefully she'll get over it. Okay, so we know that this is the formula for the pooled sample variance, so we'll need that eventually. And the other thing that I just want you to keep in mind is, just like we've seen before on any of the t-test calculations that we've been doing, we have a test statistic that's equal to the observed minus the expected value, and this is over some measure of uncertainty. Okay, and so normally when we were testing a t-test about a population mean instead of two different groups, we had x bar minus mu, right, over s over the square root of n. And so we're not going to see that change too much this time, except we're just going to put in two groups for each of these particular values. So instead of just x, we'll have the difference between the mean of x1 and x2. And then over here we'll have mu1 minus mu2, so the expected mean of the first minus the expected mean of the second. And then on the bottom of this equation, rather than s over the square root of n, we are going to have the square root of the pooled variance times 1 over n1 plus 1 over n2, which should look familiar from calculating the confidence intervals. Let's begin by talking about the null and the alternative hypotheses in these cases. Basically, we want to know, is the difference between the groups 0? Just like when we worked on paired comparisons, except this time our groups are independent of one another. Okay, so in this situation, we are asking whether the mean travel times of the two routes are different. So we want to have mu of group 1 minus mu of group 2. And I'm just, to get out of this little subscript, I'm just pushing the right arrow button, and then it'll bring it back to the big cursor. And you want to make sure that you do that, because if you leave it as a subscript, ALEKS will count it as wrong. So that might be a mistake you're making if you're stuck on this problem. Okay. And then our null hypothesis would be that there is no difference between these two groups. So this would be equal to 0. And in this case, we would want mu 1, right, the mean of group 1 minus mu of group 2 to not be equal, to not be equal to 0, right? So we want to see, are the two groups different? And then again, we are going to choose a test statistic. So remember, to determine the degrees of freedom, we want to add the number of observations in one group to the number of observations in the other group and subtract 2. And so we have 8 observations in each group. If we add those together, that's 16, and 16 minus 2 is 14. So we have 14 degrees of freedom. As I mentioned before, this is the formula for the t-statistic up here. And I've started to put in some values for the pooled sample variance, but we need the variances from our actual data set. and ALEKS has not given that to us this time. So what we're going to do is open the data in Excel. You'll note this time we have 2 columns, and we want to get the mean on this highway. We'll need that eventually. And the mean on the second highway. Okay. And then we want the standard deviation of the sample for this data set. Okay, and then we want to square these because that's the standard deviation, but we need the variances. Okay, and so we have the variance of the first freeway is 9.428. and the variance of the other freeway is 2.839. And then we can put those into the formula for the pooled sample variance. So here is the sample pooled variance, all calculated out given the numbers we got from the Excel spreadsheet. And now we need to plug in a few more values into the test statistic equation. We're starting now to fill in the test statistic information. This is the mean of the first highway minus the mean of the second highway. We got that information from our Excel spreadsheet. And the expected value is 0. Remember from our null hypothesis, we're expecting there to be no difference between the groups. And then that's divided by the square root of the pooled sample variance times 1 over n1 plus 1 over n2. So let's go ahead and solve this. Here are the calculations for the t-value, so you can pause the screen if you need some time to look over that. To find the p-value, remember in a two-tailed test, we're looking for a number that's to the left of our test statistic, here negative 2.524, but we are also looking for any value that would be greater than the positive version of this number, so greater than 2.524. And when we look at the ALEKS calculator, it only has a greater than sign. And so we want to use 2 greater than the positive 2.524, and our degrees of freedom is 14. And we're not quite done, so remember that this is just one of the 2 tails we need, so we're going to multiply this by 2 to get our actual p-value, and so our p-value is 0.024. And it asks if we can conclude that these are different at the 0.01 level. And since our p-value is greater than 0.01, we say no.